Hello. You are thanked for living in a tropical country blessed by God and beautiful by nature, right? Didn't say thank you. Not yet. Well, of course, not everything is rosy here. We have numerous social, political, and economic problems, but we can't deny we've been greatly blessed for not having to face the blizzards, tornadoes, hurricanes, volcanoes, tsunamis, and earthquakes are some examples of climate adversities. May it never happen. They happen infrequently and with low intensity in Brazil. Actually, nations facing these challenges are required to be alert all the time because triggering an event of this magnitude can have devastating consequences. That's what we're going to talk about in our video today. Currently, the United States lives under the imminent threat of the collapse of the San Andreas fault, a seismically active zone that has been dormant for many years. But it could collapse at any moment, causing an earthquake of frightening proportions. It's no accident this event, even though it hasn't happened yet, is known as Big 1-1, the Great, the Giant. However, experts have discovered an even more dangerous region which has the potential to generate much bigger and more destructive tremors. In the United States, Canada, and even in Japan, sweeping entire cities, killing and injuring millions of people and causing billions of dollars in material damages. The San Andreas fault doesn't even come close of its magnitude. That's why it's being called the big reality show, or the really big one. Click with us to learn more about this phenomenon, about how it was discovered, what the real risks involved in this event are, and whether or not it can happen. They affected us here in Brazil. There are some natural phenomena, such as storms and climate changes, that can be predicted with more ease. However, unfortunately, this isn't the case with earthquakes. Despite all the technological advancements, it is currently only possible to predict tremors to some extent, a few seconds or 2 minutes in advance. The best strategy to deal with these events is to identify the areas where they can happen more often and with greater intensity.
It is time to get a code.
In advance.
That's it.
Reinforcing structures, rethinking constructions, creating shelters, and investing in communication systems, alert systems, so that everyone can be aware and prepare. With help,
to the pussy.
Impossible to try to protect and save oneself. Well, but how can we identify a danger zone? Just understand how earthquakes work. What are the necessary conditions for it to happen, so that from this, it is possible to recognize the places that probably will be more affected currently. The entire scientific community, and most of you at home, you know the great villains behind the earthquakes and tsunamis are the tectonic plates. These plates are located beneath the Earth's crust, sailing over the magma of melted rock that surrounds the core of our planet. It's your move.
The action is good.
Is also responsible for volcanic eruptions. When magma is expelled to the surface, and by the drift of continents, which symbolizes November's slowly approaching, distancing from each other over millions of years.
It's
Love you.
fair, this movement.
More specifically, the shock or meeting of these plates that cause earthquakes. This junction point between them is known as a fault because it is at this threshold
The
that
areas
more
are-
sensitive and likely to suffer from the tremors. This is where the name originates. Commit crime San Andreas Fault. Located in California, this rift is approximately 807 miles long and cuts across the American state. From north to south, it is formed by the union of the North American and Pacific plates. It is one of the most famous in the world, even being represented in cinemas with the movie Earthquake. The San Andreas Fault, which demonstrate the potentially catastrophic effects from a disaster stemming from this Ubiriwan fissure. Well, if we know all of this, because it's not possible to predict when the quakes will happen, it turns out that plate movement isn't very orderly, predictable. Moreover, the biggest events do not happen because of the collision itself. Thus, when two plates meet and submerge, one over the other, stabilizing for a certain period, this momentary balance is very fragile, and the friction generated by the movement of one plate over another accumulates a lot of energy, which is released at once when the collapse occurs, reverberating the shock waves across the surface. The regions prone to these events, such as the San Andreas Fault, are called subduction zones, and they are known to be extremely dangerous and unpredictable because it's never known when one plate will slide over the other and release all that energy that has been accumulated over the years. The best strategy to deal with this phenomenon, at least for now, it's about using historical knowledge to determine the cycles of the tremors. Knowing about past events, it's possible to estimate when they occur. From this, we can arrive at an average that has a certain margin of error, of course, as to when another tectonic plate collapse will occur.
Sky fail! Do
There's
not attack!
significant tremors since 1857 means that a lot of energy is being stored in that area. The best estimates, they indicate that there's a chance of a major event being observed there over the years, or in the next, let's say, 30 years. It's essentially
100%.
likely that, because due to the geological characteristics there, the quakes are between 7 and 8 points on the Richter scale. Except that the recent discovery shows
Not
that
too far from there.
an event of much larger proportions is expected than this one. We're talking about the subduction zone of Cascadillo, which is located in the northwest region of the Pacific Ocean. Like betting on the fault between the North American tectonic plates, the Pacific, and a much smaller one that is between the two, the plate street of the Mendocino Triple Junction. It is 124 miles from the coast and starts at Cape Mendocino in Northern California, running over 1,000 kilometers to Vancouver, Canada, passing through major states, including Oregon and Washington. Currently, we know that this subduction zone is mainly formed by the encounter meeting between the North American and Juan de Fuca plates. The latter, being smaller, is submerged, hindering the natural movement of the larger plate. It is estimated that when this movement is released, it will produce larger earthquakes. The 9.2 points on the rigid scale being the largest in North American history so far. But why is this impending catastrophe hardly mentioned by the media? You might think that perhaps the authorities are trying to avoid mass panic, but the real reason is that until recently, almost nothing was known about this fault. Before the 1980s, experts thought that a tsunami on the Northwest Pacific coast could only be triggered by very distant earthquakes. Therefore, predicting them would be easy, even with some advance notice, so that certain safety measures could be taken. Until then, it was believed that the world's most powerful earthquakes could only occur in the region known as the Pacific Ring of Fire, the volcanic belt
We'll
rumbled,
see.
which has the planet's greatest tectonic instability. It's about a 300-mile wide strip that forms an arc. We're 40,000 kilometers long, going from New Zealand, passing through Indonesia, Japan, Alaska, going down the entire west coast of the Americas to Chile. This area of instability was responsible for a 9.5 magnitude earthquake in Chile. In 1960, by an earthquake of 9.2 on the Richter scale in Alaska in 1964, due to the 9.1 magnitude earthquake in Indonesia.
splitting
When you
the
crack,
day in
when you
two
crack,
is super
responsible for one of the biggest tsunamis in modern times, and the magnitude 9.0 earthquake in Japan in 2011, which, besides the thousands dead and injured, led to the death of over 1 million people, which caused a serious radioactive incident due to the breakdown of a nuclear plant. All of this taking into account just the last 60 years. It wasn't until the late 1960s, with the refinement of the tectonic plate theory, that the relationship was established between the movement of the plates and the seismic quakes. And it was possible to notice that this ring of fire is nothing but a ring of subduction zone. As we can see, the Cascadia Fault is part of this stable region, but for a long time, it was thought to be an inert region with no significant events, as if there was a gap in this ring of fire. The reason for that, the last major earthquake that devastated that territory happened many centuries ago, when the Pacific Northwest coast had not yet been colonized by Europeans, like the Native American people. They were the only inhabitants at the time, and they had none. A very well-developed writing system. There were no records of this phenomenon. It seemed as if it just didn't exist. The settlers who arrived in that region glimpsed the potential of the fertile land and the apparent serenity for the city to take over the territory, unaware of the dangers it concealed. Only after a long time, with the advancement of science, technology, and research, was it that set out to discover, to tell the story of that place. One of the first pieces of evidence was published in 1996 through the cross-referencing of historical data, which they allowed tracing the seismic past of the fault line. Several documents were discovered in Japan detailing a massive tsunami that had devastated the country's coast many centuries ago. The Japanese were already familiar with phenomena like this, as they live in a region of great stability. But that time was different. They felt no tremors, didn't know what had caused the big wave. This made the event known as the orphan tsunami, because it had no apparent cause. It wasn't until the 1990s that researchers were able to demonstrate that incident. It would have been caused by a magnitude 9.0 earthquake, which happened in the Cascadia Fault on January 26, 1700. Even though there are no documented records, like in Japan, scientists realized that the event was so grandiose that it was kept in the memory of the local people. It's repeated through generations via stories and teachings.
You collapsed!
The Cascadia subduction zone created shockwaves so violent it could generate massive tsunamis that swept through the Pacific Ocean until reaching Southeast Asia, causing destruction in a place that is basically on the other side of the world. And all this was discovered just by considering the accounts of people who witnessed the incident more than 300 years ago. However, the most modern investigation techniques ensure that the failure has already caused at least 41 tremors of great proportions in the last 10,000 years, as we will see next. Scientists realize that when a large-scale tremor occurs in open sea, that is, the sea is large, it leaves traces through particles that settle on the ocean floor after seismic events. Investigating the sediments in the region and conducting dating analyses with carbon-14, we were able to reach this number of events in the last 10,000 years. Making a simple calculation by dividing this time from the 41 earthquakes that occurred, we can arrive at the result of 244 years, which is the average of the cycles in which the tremors occur. Currently, we know that the last event was 315 years ago. That's why there could be another shock of unimaginable proportions at any moment. But even aren't the cycle's duration 244 years?
Hours to be more.
But this is an estimated period by an average. For example, 10 can be the average between the numbers 9 and 11, but also of the numbers 2 and 18 that are much farther away. Our best current predictions say there is a 37% chance of an event of urgent magnitude. 8.2% occur within 50 years and a chance of 10 to 15% of a collapse in the region, generating a tremor of magnitude 9.2 in the same period of time, which would lead to far greater consequences. This happens because the Richter scale uses a logarithmic calculation base.
Rhythmic. What does it mean?
Hint that the proportion of events grows exponentially as the numbers increase on the scale. So let's understand what an earthquake of this level could cause in the region. To start, all along the northwest coast of the continent, from California to Canada, it would sink at least 2 meters and move from 10 to 30 meters to SDP to Ostu. Moreover, the quake would collapse older buildings, toppling bridges, and causing serious landslides, destroying everything in its path and blocking several roads. At sea, the consequences would be even more disastrous. A large column of water would be formed. A massive tsunami would head towards Japan and the North American continent. Waves can reach up to 30 meters high and could extend up to 12 miles inland in the United States. The darkest predictions for the collapse of the Cascadia Fault estimate that the disaster could kill over 20,000 people, injure about 40,000 people, and displace at least 2 million people. All this without mentioning the billions in material losses due to the damage that will be caused to the structures, due to the shutdown of work and the economies of countries, and by the funds which will need to be invested in humanitarian aid. Although the governments of North American countries have ignored this danger for many years, either out of ignorance or lack of interest, they have currently moved out of inertia and have already started investing in technologies capable of mitigating some of the catastrophic effects of these phenomena. As we said, it's not possible to predict earthquakes well in advance, but there's still a lot that can be done. In addition to seismographs, devices that measure the movement of plates. And the incidence of the tremors, the United States is deploying a sophisticated defense system based on real-time satellite detection of the smallest changes in sea level. Moreover, there have been many advancements in the field of disaster communication that allow people to be alerted by radios, be speakers, and mainly by the cell phones, so they can evacuate critical regions and find safer shelter. We can only hope that these measures are truly effective and help prevent greater damage, saving lives and reducing financial losses. That's it. I'm signing off and see you in the next video. A big hug. Goodbye.